All right, guys, let's look up this practice test video for you. I hope it helps. Use as much as you need to. Get ready for tomorrow. Get off to a good start here in the second quarter. The first three are just like describe how the graph can be obtained from the parent function. So you don't have to graph it, just got to tell what happens. Remember those gestures we did. You have a +5 inside, opposite of what you think. So I'm going to say it shifts left 5 because it's opposite of what you think. This one's got two things going on. It's got a negative in the front. Don't forget negative in the front. Front means it reflects across the x-axis. And then it's got a 2 in the front also, which is bigger than 1, which means it's a vertical stretch by that number. Vertical stretch by a factor of 2, or by 2. I should put by 2, sorry. That says by 2. Number 3, two things going on there. It's got a -3 inside, so that means it's going to shift opposite of what you think. Shift right 3 instead of left 3, even though it's a minus. And this time there's a 1/3 in the front, which means it's smaller than 1. So instead of vertical stretch, there's going to be a vertical shrink by a factor of 1/3. You can just put by 1/3. It's fine with me. Hope that was okay. Number 4, now we're going backwards. Write an equation of a function that has that shape, the y equals x squared. Here's the deal. It's reflected across the x. That means negative in the front. Vertical stretch by 3 in the front. Shifted right 4. That means there's going to be a -4 inside. So it's going to look like this. Y equals negative. That's the reflection. 3 vertical stretch. The x has to have the x -4 inside because it's all going to be squared. The -4 must be with the x inside the parentheses to square it that way. All right, so hope that's good. Number 5, find the inverse of that. This is the hardest question on the test. I hope you're okay here. But the inverse is, remember the definition of inverse is your x's and y's switch. So you switch the first point and the second point and the third point and the fourth point. That's a toughie. You'll probably have to start that one. Number 6, determine if it's 1-to-1. If it is, find a formula. I'm going to go ahead and tell you these are both 1-to-1. That's a line, slope 5. That's definitely passes the horizontal line test. This one you can punch in your calculator if you need to. It also passes. So you gotta find both. Okay, so the way you find the inverse is you switch the x and y, and then get the y by itself. So I'm going to move the 2 over, make it x plus 2 is 5y, and then divide both sides by 5. You get x plus 2 divided by 5. And all I want you to do at the end, remember, is take out the y, replace it with the inverse of f of x. It's that notation. That's all there is to that one. Number 7, pretty good one, number 7. You got to be careful here because there's 2 x's. So when you switch the x and the y's, you're going to put the x over here. You're going to have a y there and a y here. Now watch what happens here. That's really like x over 1. So I'm going to cross multiply. I'm going this way, x times y and x times 5. And then I'm going to do 1 times that, 1 times y, 1 times 2. Now, to get the y by itself, you got to do 2 things. First thing is you got to get the y's on the same side. So I'm going to switch places with that 5x and the y. Just make sure you change signs when you do this. Just like that. And then to get the y out, because there's 2 y's, to get the y out, you got to factor it out. Okay, so I'm going to take out the y. That leaves x minus 1. Over here I have negative 5x minus 2. Now, right here it says y times x minus 1. The opposite of times is divide. So I'm going to divide both sides by that x minus 1, which means it'll cancel there. And because I'm left with just the y, I'm going to go ahead and put the inverse of f of x. And over here, the inverse, negative 5x minus 2 over x minus 1. Right, there it is. It's a pretty good one. Number 8, use composition to show that they are inverses. Like you got to prove it. And the way you prove it using compositions is you do f of g. And then you also got to do g of f. Now, this is one where you know the answer before you start. You know it has to equal x, both of them. Your job here, your answer is proving that it does. So this first one, f of g, means I'm going to take function g and plug it into f, which will look like this. I'm plugging that x cubed minus 4, where the x is, in function f. If I do that, the 4's cancel, I'll get cube root of x cubed, which is just x, which is what I needed. Then I'm going to go backwards. I can go g of f, which means I'm taking f, plugging it into that x right there. So I'm going to get cube root of x plus 4, and that's cubed. I'm just plugging it in, that x right there, minus 4. And if you cube a cube root, the cube root goes away. You get x plus 4 minus 4. That's obviously x. So what you got to prove to me is you get x on both sides, and you're absolutely good to go. All right, number 9. Number 9 says graph that and determine if it's 1-to-1 using horizontal line test. I don't have my graphing calculator here. I'm going to go ahead and just talk about this a second. First of all, it's x cubed, which means usually it's half parabola up, half parabola down. The negative sign in front of it reflects it across the x, and the 2 shifts it up 2. So it's here. And you can do this on your calculator, but on your calc, you should see this and that. It should look just like that. And you got to ask yourself, does that pass a horizontal line test? Yes. So is it 1 to 1? Yes. Number 10. Given that sine is 3/5, find the other 5. Okay, this one you need to draw your triangle. So come over to the side somewhere, draw your triangle, put theta somewhere, and it tells you sine is 3/5. Sine is opposite over hypotenuse. You need to find this third side. Now, I don't know this one already because it's 3 something 5. The most famous right triangle in the world is 3, 4, 5. If you need to use Pythagorean theorem to find that side, then do that. Okay, now it's asking me for cosecant. Cosecant's reciprocal of sine. Didn't even need the triangle for that answer. It's just 5/3. Cosine is adjacent over hypotenuse. The adjacent to that theta is a 4. The hypotenuse is 5. Secant's reciprocal of cosine. So you just flip that answer. Tangent's opposite from theta over adjacent to the theta. No hypotenuse. Cotangent is reciprocal of tangent. You just do 4/3. All right, and 11's another one just like that one. So I'm going to draw another triangle here. I'll show you all the work this time. Maybe that'll help. It says cosecant's 2/3. Now, that means sine is 3/2. Those are reciprocals. You need to know that sine and cosecant go together. Okay, if sine is 3/2, that's actually kind of crazy. That's not a very good example. Let's do this. I'll need to do this in class. I think I did this in class too. Should have. Let's change this one to 3/2. Okay, so let's say the cosecant's 3/2. That means sine is 2/3. The reason I'm doing that is sine is opposite over hypotenuse, and hypotenuse has to be bigger. So sine and cosine have to be less than 1 every time. So that was a misprint there. Okay, if sine is 2/3, I'm going opposite over adjacent. Opposite over hypotenuse, 2/3. I need to find the third side. So I'm going to do 2 squared plus b squared, I don't know what that is, equals 3 squared. Just do Pythagorean theorem. 2 squared is 4, 3 squared is 9. If I move that over and do 9 minus 4, that's 5. If I take the square root, I get square root of 5. So this side right there is square root of 5. Just put it out right there. Okay, so cosine. Cosine is adjacent over hypotenuse, which is square root of 5 over 3, which means secant is the reciprocal of that, which is 3 over the square root of 5. And remember how we simplify that. We move the square root of 5 to the top, take the 5 out on the bottom, and there you go. Tangent is opposite over adjacent, which in this case would be 2 over the square root of 5. If you rationalize, you get 2 on 5 over 5. Again, just move the radical to the top, take the number on the bottom. Cotangent's reciprocal, do the easy one. Do reciprocal of this one. This would be square root of 5 over 2. You can flip either one of those you want to, but it's so much easier to flip the easy one. All right, number 11. 11, that was 11. It's really 12 and 13. I did a great job on this test. Okay, so it says find cosine 60. You need to be able to draw that 30, 60, 90 triangle. And for 13, that 45, 45 triangle. Cosine 60. If you can draw the triangle, you got it. Okay, cosine is adjacent. So adjacent of the 60 is right here, the 1. The hypotenuse is the 2. So cosine of 60 is 1/2. All there is to it. Sine 45. If you can draw the triangle, you got it. You have 2 45s. You got 2 choices here. Remember, sine is opposite, which is 1, over hypotenuse, which is square root of 2. So you get 1 over square root of 2. Rationalize, put the square root on the top, take the number on the bottom. You got it, square root of 2 over 2. Last page. Okay, already done 11, 13. So I got 3 more here. Got 14, 15, 16. All right, 14 says find f of g of x. We've already done that once or twice in this test. And the domain for that. So f of g means I'm going to take function g right here, function g, and I'm plugging it into f. So if I do f of g, it's going to look like the square root of, come on now, square root of x squared minus 5 plus 5. Obviously, the 5's cancel. It just gives me x squared, and the square root of x squared is x. So that's the first answer. That's the f of g of x. Then it says find the domain. Now here's how you find domain. You found the domain of the second letter, the second function, which is g. Now that domain right there, there's no fractions, no square roots, so it's just all reals. And then you look at your final answer. The final answer was x. It's also all reals. So since they're both all reals, the domain for the whole thing is all reals. But the way you do that again, the domain of your second function what that has in common with the domain of your final answer. Okay, so that's how you do domain for composition. Number 15, determine algebraically if it's even, odd, or neither. This is going to be fun. Even, remember, you plug in a negative x and see if you get the same thing you started with. If you plug in a negative x, it looks like 4 negative x cubed plus 3 times negative x minus 2. And that's the same thing as this. Because those are odd exponents, the signs get changed. It becomes negative 4x cubed minus 3x minus 2. And you got to ask yourself, is this the same thing that we started with? And the answer is nope. So that means it's not even. I know it's not even. Now to test odd, you plug in a negative y and a negative x, which means I'm going to plug in a negative on this side and also a negative on the right hand side, which I've already done. So I'm going to pull this right here just back down here because I've already plugged in a negative x. Again, this is what I got. So I'm looking at this whole thing and asking myself two questions. Is it exactly the same as what we started with? No. Is it the exact opposite of what we started with? No, because of the minus 2. So is it even, odd, or neither? It is neither. Now, one thing about this that I should have thought of here at first is, my phone's blowing me up. Because the exponents in the problem are odd, there was no way it could have been even. It doesn't mean it's odd, but it could not have been even. All right, last one. Number 16. 16, there's 3 parts. You got to give 3 answers. The first part says g of negative 2. You got to figure out where am I going to plug the negative 2. Well, since the negative 2 is less than 1, I'm going to plug it in for that x, negative 2 plus 4, and you get 2. There's the first answer. Second answer, g of 1. I'm going to plug in 1. I'm also plugging it in up here because it says less than or equal to 1. If I plug in 1 there, I get 1 plus 4, which is 5. So the second answer is 5. And the last one, g of 5. 5, I'm plugging into this one because 5 is bigger than 1. I'll get 8 minus 5, which is 3. So the 3 answers are 2, 5, and 3. Hope this helps you. Come see me if you need to. I'll be there early tomorrow and all day long. So come see me if you need help. Be glad to help you. And see you then.